Hello guys, welcome back to the channel for another Databricks video. As you know, this is a series of tutorials that would help you understand Databricks better. I try to cover most of the things you would see in the Databricks Academy training. More or less, we have seen most of these things in the past, but on these videos I try to put things together so you don't just see bits and pieces. Today's video is about streaming design strategies, or in other words, how to use structured streaming. Of course, there are plenty of ways to develop stuff, as we all know. There is no one-size-fits-all in coding, but here we are going to see the basics. Before we dive in, let's revise the multi-hop or medallion architecture briefly again, and then we will see the code. So, let's revise the medallion architecture or the multi-hop architecture. Very briefly, of course, we have the source, whether it's a database, JSON file, CSV file, or Kafka, whatever, it doesn't really matter. Our landing zone is the bronze layer. And from the bronze layer that we receive all the unprocessed data, and we store all the unprocessed data in the original format. We don't change anything. We store the data there, so it's a landing zone. And then we move the data from the bronze layer to the silver layer after having deduplicated the data, or we have enforced the schema, we have performed quality checks, and usually we have our data model there on the silver layer. The last step is the gold layer that has aggregated data. So we aggregate the data, and sometimes we build star schemas on the gold layer, so the data is ready for reports, dashboards, ad hoc queries, etc., etc. Let's see one by one what those layers represent. So the bronze layer represents the unprocessed history of the data. We capture the provenance of the data loaded into the lakehouse without parsing or making any changes. So we keep the data in the original format. It should be append only, whether it's batch or streaming, it doesn't matter. We just append the data. We dump the data on the bronze layer. We don't want any updates or whatever, anything like that. It's just append only. And we try to retain all the records when possible. And the reason is, at least one of the reasons is, if there is a problem downstream, and there are some data missing or whatever, we can come back to the bronze layer and get the data that we need, right? Simple as that. Now on the silver layer, the silver layer preserves the grain of the original data, so we don't perform any aggregations there, but we eliminate the duplicate records, we enforce the schema, we perform data quality checks, and we quarantine corrupt data. And usually, as we mentioned, we have the enterprise data model there. The gold layer now contains the aggregated data that is ready for reporting, dashboards, ad hoc analytics, etc., etc. And usually the ad hoc queries are much cheaper to perform on the gold layer than on the silver layer. And it also allows fine-grained permissions. Now that we have seen the medallion architecture, let's move to structure streaming and incremental ETL. The first thing we have to do is actually create the bronze layer. I'm going to use this script here, this DDL, to create the bronze layer. We have a very simple table. We have the ID, which is an integer, the first name, which is a string, the age, which is a double, so it represents, let's say, a person, right? And we insert those values into the bronze layer table. So let's run this one. And then let's actually select those values from the table to see that everything is okay. And it should be okay. Yep, number of affected rows is 3. So we expect 3 records on the bronze layer. Now, okay, we have the bronze layer here. You can see the data. Now, the next step is to move the data from the bronze layer to the silver layer using structure streaming, right? So using structure streaming, we add the field to capture the timestamp, which is the current timestamp of the time of processing, of course, and write the data into the serial table as a single batch. While this code uses structured streaming, it's appropriate to think that of this as a triggered batch processing incremental changes. So essentially it is structured streaming, but you can run it, if you don't run it continuously, it's not streaming. It's like uh, uh, batch processing, right? We can use trigger available now to slow down the processing of the data combined with query await termination to wait until the one batch is processed. Trigger available now is very similar to trigger once, but can run multiple micro batches. So let's see what the documentation says about that. So we have once, which if this is set to true, set a trigger that processes only one batch of data in a streaming query, then terminates the query. And then we have the continuous, which is proper streaming and available now. If this is set to true, it's actually like once, but it processes the data in batches, in micro batches. Pretty simple, right? So let's run this code here. We have to import the functions, of course, the PySpark SQL functions. And here we have this query, which is spark.readStream. Remember, it's structured streaming, so it's read stream, not just read. From the bronze layer, that's the source. With column, we add the process time column, which is the current timestamp. And then we use write stream because it's structured streaming. Option, we have to, when we have structured streaming, we have to define a checkpoint location. So we know the state of the data at at every second, right? At every second, at every moment. And I have used the file store, the DBFS here, and we use trigger available now true, and the table is called silver layer, and await termination. So let's see what the documentation says about that. Waits for the termination of this query either by query.stop or by an exception. If the query has terminated with an exception, then the exception will be thrown. Okay, so we have timeout as well. Okay, let's run this one and let's call it, because now we run it, but it's not actually being run until you call it. Okay, the job finished, and here if we select from the silver layer, we will see the data that we had on the bronze layer plus the timestamp column here, the processed time. And yeah, that's it. Pretty simple, right? We move the data from the bronze layer to the silver layer using structure streaming. Delta Lake is ideally suited for easily tracking and propagating inserted data through a series of tables. This pattern has a number of names, including Medallion, multi-hop, Delta, and bronze, silver, gold architecture. Yeah, we mentioned about that. Writing to multiple tables. Now that's interesting. So instead of, let's say, we have the data on the bronze layer and we want to write the data into multiple destinations, into multiple tables on the silver layer, right? How can we do that? Because you cannot do it using this code here. As you can see, we define one table here, not multiple tables. And how we can do that? We can use for each batch. This method provides an option to execute custom data writing logic on each microbatch of streaming data. So actually, if you think about it, we are streaming data, but also we are using this for each batch method. We process micro batches of those streaming data. Pretty cool if you think about it, right? The Databricks guarantees that streaming Delta Lake writes will be idempotent even when writing to multiple tables if you set TXN version and TXN app ID options. So let's see what the documentation says about that. Idempotent table writes in for each batch. Okay, so Delta tables support the following data frame writer options to make writes to multiple tables within for each but idempotent. App ID is a unique string that you can pass on its data frame, right? For example, you can use the streaming query ID as app ID and TXN version, a monotonically increasing number that acts as transaction version. So if you combine that, it would be easy for structured streaming for Spark to identify duplicates and ignore them. Perfect, right? If a batch write is interrupted with a failure, rerunning the batch uses the same application and batch ID to help the runtime correctly identify duplicate writes and ignore them. Application ID can be any user-generated unique string and does not have to be related to the stream ID. Perfect, perfect, perfect. Let's go back to the code and see what we have here. So our function here, toStreams, as you can see, it has a query. And the query is similar to the previous one up to this point. So we have spark.readStream table bronze layer. We read the bronze layer again, and then dot write stream. And before we actually save the data into one table, we use the for each batch method. And we pass the name of our method, which is defined up here, write to sinks, and this one, so we pass as a parameter, and this function here, a custom made function that we are using to process micro batches, we have to pass the data frame and the batch ID. Now, apparently the data frame is the data frame that we are using here from reading the bronze layer, the data from the bronze layer. And here we can use whatever app ID we want, just a string, whatever string you want. The batch ID is auto-generated, but of course you can use a custom-made batch ID. And here, the data frame, we can select the columns, ID, first name, current timestamp. We again we have to add the current timestamp, a new column, and then dot write option, the TNX version, batch ID, and app ID, TNX app ID, the string that we defined up here, mode append, save as table, serial first name. So again, as you can see here, we get the data essentially from the bronze layer, and it's like batch processing because we select the columns from the data frame and we use dot write, not dot write stream, right? It's different. Dot write, we pass the options here, so we don't get duplicates, etc., etc. And mode append, and whatever comes from the bronze layer, we save it on the serial layer with this. We save it as this is the table name, silver underscore first underscore name. We save it as table. So that's one table from the data using from the bronze layer. And then we have a second table that we select the ID and the age. And of course, we create another, again, the timestamp column, and we use dot write, dot option, the version, batch ID, and app ID, which are the string that we defined up here again, mode append, save as table, silver age underscore age. So we save the data, we split the data into two tables, and we save them on the silver layer. Again, because it's actually structured streaming, although we're using for each batch, which is batch processing, but for micro batches. And then here we have, because it's structured streaming, we have to define a checkpoint location. Again, that's in our DBFS. For me, you can use whatever you want. And trigger once true dot start. So if we run this, it's going to create two tables on the serial layer. And although it's structured streaming, using for its batch method, we are processing the data in micro batches as they come, and we can actually have two destinations. If we run this, let's run it. And let's see the data. As you can see, batch ID is on equals 0 the first time, because that's the first time we run it, right? And now if we select from the serial layer, from the first table that we created up here, you can see the data ID, first name, process time, and then the second table, silver underscore age. You will see the second table on the serial layer, ID, age, process time. Pretty simple. Now, if you notice, although we process the data at the same time, it's not exactly at the same time, although it's inside the same method. As you can see, they are completely independent from each other. So there is a difference in the time step if you notice. So that's 18:53:37, and here is 18:53:39. 2 milliseconds difference. So just just as a note, don't be surprised if you see some differences, some discrepancies between the processed times. Moving on, we have update aggregates. Incremental aggregation can be useful for a number of purposes, including dashboarding and enriching reports with current summary data. So the logic below defines a handful of aggregations against the silver table. It could be, as a source, we could use the bronze layer instead of the silver layer. It doesn't really matter. So we can, again, we use structure streaming. So spark.readStream table, we use the serial layer as a source. We group by ID, and we perform aggregations here. We use the sum method to calculate the total age, and the min method to calculate the average age, and the count to get a record, the count of the records. And then dot write stream, we define the checkpoint location, and then we have the output mode is complete. Now this is what that means. Actually, if we check the documentation, output mode equals complete. Output mode in which all the rows in the streaming data frame dataset will be written to the sink every time there are some updates, because we have three modes: append, complete, update. Append output mode is in which only the new rows in the streaming data frame dataset will be written to the sink. And the update mode is output mode in which only the rows that were updated in the stream data frame dataset will be written to the sink every time there are some updates. Or this one, this documentation here, this tutorial, I think it describes that a little bit better. Use complete as output mode when you want to aggregate the data and output the entire results to the sink every time. So we override the data, right? We override the data. It's not append. This mode is used only when you have streaming aggregated data. And yep, and in case if you use complete mode on non-aggregated stream, you will get the exception below. Complete output mode not supported when there are no streaming aggregations on streaming data frames datasets, right? So, but here we have aggregations. We perform aggregations here. We don't have to worry about that. And we write the table into the data into the table silver underscore aggregates. Let's run this one. Define aggregates, and then we can query the table, and we can see the aggregate. Give it some seconds. I'm using the cheapest cluster I can use. Apparently, when you are performing demos with shoestring budget, yeah, you can use the best cluster or the most expensive one. So I have to actually compromise with the cheapest cluster I can get. And here you can see we perform the aggregations and we have the silver underscore aggregates table. One thing to note is that the logic being executed is currently overwriting the resulting table for its write. Yeah, as we mentioned, using the complete mode, we overwrite the data again and again. If you don't want to overwrite the data, you can use the merge statement within the for each batch method. We are going to see an example of using the merge statement within the for each batch method using CDC data. So what we have here is processing change data capture data, or actually simulating CDC data, because every system is different. The format of the CDC records is a bit different from system to system. It differs. So let's say that we have a database, we have enabled CDC, and these are the this is the CDC table that we have, which has the user ID, the first name, and the update type, the process timestamp. Okay, that's nothing unusual here except the update type. And this is where the CDC table in the database provides this information, whether the record was insert or it was update or was delete, right? So we have this information here. And usually every when you have enabled CDC on the database, you have this information. Was this record inserted? Was it updated? What was the new value? What was the updated value? If it was deleted, we know. So let's actually run this script here that creates a, let's call it bronze underscore CDC table with this data here. Let's query the data. Actually, it's not essential. So let's actually create silver CDC table, the same with exactly the same schema, except for the update type, which is not useful on the silver layer because we are going to perform the merge statement, and this is where we would use the update type. So moving on, we have the merge statement can easily be written with SQL to apply CDC changes appropriately given the type of update received. So here we have our typical query, spark.readStream from the bronze CDC table, writestream.writestream for each batch, and here we call our upsert underscore CDC method. We have our data frame here, the batch ID, and here we create a temporary view of this data frame called bronze CDC underscore batch. And here we use the merge statement. Now notice, as a source, we use the bronze CDC batch table, which is this one up here, right? We use on the join, we use the user ID to join the source user ID with the target user ID, which is in the silver table. Target is the silver underscore CDC table, right? And the source is the bronze underscore CDC batch table. So as you can see here, we have named that with S. Here, the alias is B. So B.user ID equals S.user ID, right? So we join based on the user ID. And then when matched and B.update type equals update, then we perform an update on the target table. Then update set user ID with a new user ID, which is the same actually, and we actually update the first name and the processed timestamp. We update those columns, and then we have when matched and update type is delete, then we delete the record, and when not matched this time, and update type equals update or insert, that means that this record exists in the source but doesn't exist on the target table whatsoever. So we have to insert a new record to the target table. That's why here we have insert and the values, right? So if you're familiar with merge queries, you know what we are doing here, nothing new. And here we execute the query using the Spark session. And if we run this code here, let's see what we get. On the serial CDC table, we will have, of course, the original data, but then let's actually query data from the silver table. We have the original data, but then let's actually update the bronze layer, the bronze CDC table, with those data. As you can see, we have the same IDs 1, 2, 3, 4, and 6. I think we don't have 6 here, right? So 6 could be the new record, and the other records will be updated. Let's run this one. We insert the data on the bronze layer, and then we run the merge statement using for each batch method and performing the merge operation. As you can see, the merge operation is running. And now if we query the silver table, we will see the updated data. You see, we have a new record and the other data, the first names got updated. Moving on, we have joining two incremental tables. There are many intricacies around watermarking and windows when dealing with incremental joins, so not all join types are supported. But here, for example, we read this silver underscore first underscore name table and the silver underscore age table. These are the two tables that we created before. So we use structured streaming to read the data. One is, let's call it first underscore name data frame, and the other one is the age data frame. And we perform a join here based on the ID, and we select the ID, the first name, the age. We provide the current timestamp, and we write the data into this table, incremental joint streams. And of course, it's structured streaming, so we have to define a checkpoint location. So, right, nothing difficult. We perform a join here based on those two tables. Let's run the script. And here, let's start running that. You can see there is no trigger option. There is no trigger option here, right? So that means the stream will run in continuous execution mode. So it's actually streaming. This is streaming now, triggering every 500 milliseconds by default. As you can see, it is running, stream initializing, etc., etc. So we cannot use our wait termination here because the stream never stops, right? But we can see the data using display, and we read from the target table. This is the target table that we store the data. So if we display the data here from the target table, we should be able to see what has been inserted so far. Of course, it's in continuous mode. So every update we make, then it should display the new data. Now, so this is the data that we have currently that we are streaming. But let's say that we insert new data here, right, on the bronze layer. Then from the bronze layer, we are going to move the data to the silver layer. Remember that we have this method that we split the original data into two tables, and those two tables are actually the silver tables that we use here as a source on our streaming query. That means here it should display the new data in a few seconds. Did it run here? Yep, it runs. So anytime soon we should get the new data. Okay, here we are. As you can see, we got the new data. So this is actually streaming, right? And this is how you can use the continuous mode. If you want to stop the streaming mode, Now, interactive streams should always be stopped before leaving a notebook session, as they can keep clusters from auto-terminating and incur unnecessary cloud costs. We don't want to do that, especially when we are using our own account, our private account. So you can terminate the streaming job by clicking cancel on the running cell here, interrupt, stop execution, or by running this code, we see which streams are active and we actually stop them. Perfect. The last example is about joining incremental and static data. In the previous example, we joined two streaming tables. Now one it would be a streaming table and the other one would be a static table, right? So here, for example, we use silver CDC as a static table. That's why we have .read, not read stream as we have here for the bronze layer. And then we use joins, the typical join here based on ID. We select all the columns from the bronze layer and we use .write stream. We define the checkpoint. You can provide a query name if you want and the table. So if we run this one and then run this one, we should be able to see the data. Yep, here it is. As you can tell, it's not so different than joining two streaming tables, same syntax, etc., etc. Let me interrupt this one. This is it for today, guys. We have done those things before. I don't think it's something new to us, but here the code goes a bit more structured so everyone can follow. I hope you enjoyed the video. Please click the like button, leave a comment, subscribe to the channel, and I will see you in the next one. Thank you.